Just one more thing about the frogs. I was reminded reading this. The New York Times article says, 10 years ago, these people would have been doing ayahuasca in, yurts in the backyards of people in Southern California, and now they're doing combo. And, it definitely, it invokes an image. I got it. I'm right there. And it also invoked for me, however, it reminded me of my very first study abroad program, not actually at Evergreen. I ran a study abroad program, as you know, through an independent field school before I started at Evergreen after I got my PhD. And I had students, none of whom I'd met before, meeting them in Panama. We're in Bocas del Toro archipelago. And I had students from the US and from Europe. And after one of the first days of field work, where they were supposed to be collecting some data on their own, a couple of the guys came back and told me they'd licked some frogs. And it's like, guys, you have no idea what you're doing. Like you heard somewhere that some frogs will get you high. And this is really not a safe practice.
Oh boy.
This is really not a safe practice. But amphibians are actually really well equipped to hurt you, and they don't have fangs. Like they don't have teeth. Well, no, so many of them, the ones they were licking, don't have teeth. Some of them do, but they don't come with spikes and horns and claws and such. They come with the poisons in their skin, and not all of them are. But for God's sake, get it right. Like, do your research.
It's frog roulette in the neotropics to be.
Yes.
So it is. So first of all, just to wrap things up nicely, the idea that harassing frogs causes them to exude this substance makes perfect sense behaviorally, because in general, it doesn't take much contact with a toxin for a predator to realize, I don't want to eat that thing, which means that in many instances, the animal will not be killed at the point that the predator realizes it's made a mistake. Right. So, toxins tend to be very, very bitter. And in fact, if I can confess, the quick and dirty way of figuring out whether some fruit you found in the rainforest is okay to eat is to take it and dab it on your tongue. And in general, the stuff that you shouldn't eat is bitter as all hell. And the stuff, spondius, what I love finding on the forest floor, which is perfectly edible and delicious.
Spondius mombin, that's the scientific name of this beautiful, it's canopy tree, right?
Yeah. Oh, yeah.
With fruits that must be dispersed at least in part by monkeys, because we like it too.
Yep. It's monkeys and bats, I believe, are the primary dispersers. Monkeys sometimes being lousy dispersers because they will sit in the tree and eat all day and drop the seeds right into the tree, which the tree can do itself without making a fruit. Bats
we don't need to send it through a monkey to do that. Thanks much.
Right. So bats are great dispersers. Why? Because two reasons. One, they fly, so they tend to, if they swallow the seeds, they'll crap them out somewhere else. But they also have a very fascinating aversion to hanging out in fruit trees. Even the ones that eat only fruit don't hang out in the fruit trees. And the interpretation of this is that those fruit trees attract predators looking for fruit dispersers. And so the fruit tree is simultaneously a source of food and a very dangerous place to be, which it's possible that the fruit trees actually have a branch structure that increases the likelihood of predators to be there in order to make the frugivores nervous, so they'll leave and go do a good job of dispersing.
I love
anyway,
this.
It's an interesting story. But the point is, your students who licked these frogs probably would have the experience, if they found a particularly toxic one, would probably have the experience of making their mouths very numb and tasting something very bitter and realizing they'd made a mistake. But there is the occasional...
Numb is only one. So numb would be the effect from the dart poison frogs. As I have stories about that. Maybe I'll share one of them here today. But some, I don't think combo actually produces, for instance, numbness. It's not going after sensory neuron synapses.
But I would just point out that in the dendrobatids, this is really your story, but in the dendrobatids, there are the occasional frog that is so toxic that mere contact with the animal is enough to knock a person flat on their ass. So Phyllobates terribilis.
Right. Had we been in a place where that was true, I would have obviously provided them that information in advance and told them to stay the hell away. And in fact, across, it's since been developed, which is a terrible tragedy, or at least it was in the process of being developed, and it's possible it got stopped. But there was this is related but not quite the same, the highest density known of eyelash vipers, which is just this beautiful snake named because it has these scales above its eyes that look like they're wearing this fancy fake eyelashes. And they're tree snakes, and they come in a plethora of colors. They, usually in the rest of their distribution, the rest of their range, they're yellow, but on the Sarepta Peninsula, which is just a short boat ride away from this field station we were at, there's sometimes pink, there's sometimes green, there's sometimes pale with some splotches. And I had actually one of the students who had looked frogs earlier ended up doing some research on these snakes, but I was over with him for the first several times that he was there, and I made sure that he was not acting like a yahoo, because you cannot operate the same way in a tropical forest as you do in a temperate forest, or anywhere in a place that hasn't been made safe for you. Because there is no one who could possibly make it safe.
Yep. Yeah, and eyelash vipers being one of these things, even those of us who are used to dealing with poisonous snakes, right? The eyelash viper is where you put your hand, which is not the usual for such an animal.
Yeah, and they're little too, and they'll bite you.
Little and inconspicuous, and so as you know, I have a hypothesis about what the value of the eyelashes on the eyelash viper.
I find this okay. You're gonna do it. You can
one
save
of my
it.
favorites. No, I'll use it.
Okay.
Why not? So unfortunately, we don't have a picture of this animal, or this would be much more. Yeah, can you get one?
Well, even if I could, I don't. No, I can't.
Okay. So the eyelash viper has these little, it's scaly. It's basically the same material as the face of the animal, and it sticks off above the eye. And these are little vipers that hang out on various plant parts and wait for prey. They're sit and wait predators, and being camouflaged is key to their niche. And so, as Heather mentioned, they're tremendously large number of colors, even within a brood, as I understand it. Mm-hmm. You can get many different colors, which means...
So I wish we had one of our pictures. Like, you and I both have taken some beautiful pictures, but here's one. This isn't a very good picture. Here's one again showing
the face.
Yeah, it's tiny though. Yeah, it's not. These aren't great pictures, and I didn't prepare for this, so I don't have any of ours. Anyway, keep going.
Oh, but there you go.
That's not bad.
That's not bad. Mm-hmm. Can you show it? Can you full screen it?
Not really.
Right click on it, say view image.
There we go. So there you can see the little eyelashes that stick off above the animal's eye. So the hypothesis, and again, this is a hypothesis as far as I know, completely untested. In fact, I don't think anybody has taken it seriously. But
no, I didn't.
I know. See, look at you. You're
I'm
smiling
sorry. I just
there.
remember you doing this in class, and it was the first time I heard it when we were teaching together, and I think I just started laughing.
But you have no idea. This warms my heart so to be the only person who believes in something. And then, if this turns out to be right, which I think is pretty likely. Yeah,
I'll be thrilled.
But anyway,
that doesn't mean it's not ridiculous.
It is. It's nature is ridiculous. So the hypothesis is that this animal, in order to do what it does, needs to find a place where it is camouflaged in order to sit. And because you have many different color forms of these snakes within a brood, you can't just wire in, you're a light green snake, look for light green places to hide, because the animal doesn't really know what color works, right? Because it could be any color. And so if the genome had that programmed in, you'd somehow have to coordinate the color of the skin with the preference in the eye, and that's not an easy job to do. So what about having a little eyelash that sticks up that allows the animal to look around and match its color to the substrate on which it's going to sit? So
my point is, why they're snakes? Why don't they look at their own tail? I don't. That's cool, but they're snakes. They have a lot of body that they can look at, and they're pretty much the same color.
Okay. But if the animal is looking around, by definition, it will have its eyelashes right where it's looking, right? Whereas having to sit somewhere and pull its tail up and match it up to some flower, while that would also be a cool adaptation, I don't think it's nearly as cool as having just a little thing. So this makes predictions. One prediction is that the eyelashes are within the view of the animal enough to work this way.
And you're going to find this out through interviews, or?
Yes, that's how I'm going to find it out. I'm going to ask the animals if they can see their eyelashes. But also, the prediction would be that the eyelashes are never of a different hue than the animal, right?
True.
So anyway, things like that. So this is how we entertain ourselves.
It is this and pinheaded shrews. So there you go.
The last thing.
Yeah. Yes.
As long as we're on the topic. Amphibians, toxic. Our newts, our local newts here, are maybe the most toxic pound-for-pound animal on planet Earth, which was discovered through an accident where some hunters, I believe, had accidentally scooped a newt into a coffee pot and then boiled the water to make coffee and were found dead. And this alerted people, these must be very toxic animals. They searched, and something like there's enough toxin in an individual newt to kill 50 average people, something like that.
Yeah. And I believe the story is not specious, that the people in North America who then did work on Tarica granulosus and isolated the molecule, which they called Tarica toxin, based on the genus name of the newt, the Latin name of the newt, Tarica, went to present their work at some big toxicology conference or some such, some few decades ago. This isn't 100 years ago. This is fairly recently. And in the audience, I think I'm getting the details right, and I think this is a true story. In the audience were the Japanese researchers who had worked on the toxin that the pufferfish, the genus for which is Tetrodotus, I think, or I may have that quite a little bit wrong, but they actually were presenting at the same conference, tetrodotoxin, which is the toxin of the pufferfish. And I don't remember who was up first, but either the Tarica toxin guys with the newts or the tetrodotoxin guys with the pufferfish toxin were up there presenting, and the other people were in the audience, and they looked at the molecular description, the chemical description of the toxin, and went, "Oh my God, it's the same thing." So it turns out pufferfish in the Western Pacific and newts on the west coast of North America, separated by a large Pacific Ocean across which the newts cannot cross and the pufferfish do not cross, have convergently evolved exactly the same toxin.
Right, which makes a weird kind of sense, because all of these toxins are basically interference molecules with the physiology of critters. And to the extent that critters are variations on a theme, there's a limited number of molecules you could build, and there will be selection for that which most effectively disrupts the creatures in question. And so it's not surprising that selection again and again finds, you would expect it to find analogs. You would expect it to disrupt the same system. What is a little surprising is that it finds exactly the same structure that interfaces with.
Right. And in that case, not because, as I already mentioned, the dark poison frogs in the New World, the dendrobatids and the mantellas, the poison frogs of Madagascar, have converged upon exactly the same lipophilic alkaloids. But we can trace that to an environmental similarity, which is that the building blocks for those alkaloids are in the mites and the ants that they eat. Even though the species of ants and mites, like the species of frogs themselves, are so distantly related in Madagascar versus the New World, despite having a Gondwanan distribution that is shared. But we're talking about tens to well over 100 million years since Gondwana has been separated. Anyway, that biogeography for another time. But which is one more thing about these frog toxins. When I was in the business of tattooing frogs, which I remember this well, for a spell, only because I needed to mark them in order to know who was who, in order to do the behavioral work that I was doing on them. And I tried putting little beaded waistbands around them, and I tried a number of things, and none of it worked. In part, it turns out that frogs have neither necks nor waists, really. Or they have waists that if you cinch something tight enough, you're going to hurt the frog. And these are little tiny frogs. So I ended up tattooing them, which didn't please them too much. And you have to be really careful. They've only got 2 layers of skin to R3, so you have to be very, very careful. And I had this little handheld tattoo machine that was part of my field gear in Madagascar. But much like the people in the Brazilian Amazon who use various toxins as tips for their darts, or as purgatives for their own health, you have to aggravate the frog in order to get them to start producing this white milky toxin on their skin. And I was never trying to. That wasn't part of my research. I wasn't studying their biochemistry or their toxins. But what I found was that when a frog was particularly squirmy and I had to really, hold it for a while in order to get it tattooed, that even when I wasn't aware of it, if I had spent a morning tattooing frogs, and then was uncareful in the way that many of us discovered we were at the beginning of COVID, and often touching our face and such, that if I touched my fingers that had been on the frogs to my lips or any mucous membrane or any cut, I would get a quick burning followed by numbness that would last for anywhere from a few minutes to up to an hour or two in one case. And that this was very clearly the toxin, the lipophilic alkaloids in these frogs, that was doing its work, which is, as I mentioned earlier, blocking the synaptic transmission of sensory neurons.
Hence the numbness. Yeah.
Hence the numbness.
Makes perfect sense.
Yeah.
I should just say, because certain people will be wondering, yes, you had a tattoo gun on your study island in Madagascar, and because the days are long, there's not a whole lot to do, you also at one point did my tramp stamp, and I think you did very excellent work.
Oh yeah. Are you going to show it?
Not today.
No.
No.